chlorine. Atomic number of chlorine is atomic number of chlorine 17. Atomic number of chlorine Cl 17. Okay, 17. Atomic number of chlorine 17. And suppose its mass number is 35. Mass number here it is 35. 17 represents atomic number. 17 represents atomic number. And 35 represents mass number. What is atomic number? Samakr, what is atomic number? What is atomic number?
Sir, atomic number is the number of protons present in the nucleus of an atom of an element.
Yes, the number of proton present in the nucleus of an atom of an element is called atomic number. And what is mass number? What is mass number? Aryavir, what is mass number? The total number of protons and neutrons present in the nucleus of an atom of an element is called mass number. Aditya, in this case, what is the number of neutrons? In the case of chlorine, number of neutrons is equal to what is number of neutrons?
That neutrons. That neutrons is given as 70.
Why? What is the formula to find number of neutrons? Number of neutrons is equal to mass number minus number of protons or atomic number. 35 minus 17, that is equal to 18. So, number of neutrons present in this chlorine atom, that is equal to 18, and number of neutrons. And one more chlorine atom, atomic number 17, but mass number is 37. Mass number here it is 37. In this case, number of neutrons is equal to how many neutrons are present here? Jia, how many neutrons are present? 20. Number of neutrons is equal to 20. Why? 37 minus 17. 37 minus 17, that is number of neutrons. Now, you have to check these two chlorine atoms. In this two chlorine atom, atomic number of these two chlorine atoms are same. What is the atomic number of these two chlorine atoms? 17. 17. Atomic number that is same, that is equal to 17. But here mass number is not same. Mass number is not same. Such atoms are called isotopes. Such atoms are called here isotopes. So, what is isotopes? Isotopes are atoms of same element. Isotopes are atoms of same element. Isotopes are atoms of same element having same atomic number but different mass number. Isotopes are the atoms of the same element. Isotopes are the atoms of the same element. Here element same because atomic number same. So elements are same but different mass number. Different mass number. Atoms of the same element having same atomic number but different mass numbers are called isotopes. Atoms of the same element having same atomic number but different mass number, that is called isotopes. What is isotopes, Vedant? What is isotopes?
Elements are same atomic number but their mass number is different.
Atoms of the same element having same atomic number but different mass number are called isotopes. So isotopes are the atoms of same element having same atomic number but different mass number. And what is the reason for this isotopes? Because these two elements have difference in the number of neutrons. Because of the different neutrons present in the nucleus. Because of the number of neutrons present in the nucleus, that is different. Because of this different neutrons, the mass numbers that also will change. The mass number that will change because mass number depends upon number of neutrons. The number of neutrons are different. The number of neutrons present in the nucleus of chlorine atom, that is different. In the first case, number of neutrons equal to 18, and the second case, number of neutrons is equal to 20. Because of this number of neutrons present in the nucleus, difference in the number of neutrons present in the nucleus, the mass number that is also will change. That is a reason for the isotopes. What is isotopes? Atoms of the same element having same atomic number but different mass number. The two isotopes of chlorine, 17Cl35 and 17Cl37. And the different isotopes of hydrogen, very important. The name of the different isotopes of hydrogen, that's also very important. The different isotopes of hydrogen. The first one, 1H1. In this case, what is the number of protons present in this isotope of hydrogen? Number of protons, 1. Number of protons is equal to 1. Yes, number of protons, that is equal to 1. Or number of electrons, 1, because atom that is electrically neutral. And mass number, 1. Number of neutrons, yes, very good, 0. Number of neutrons, that is equal to 0. 1 minus 1, that is equal to 0. And the name of this isotope is protium. So, in the isotope of protium, in the isotope of hydrogen, that is the name of that isotope is protium, number of neutrons present is equal to 0. Number of protons equal to 1. Number of electrons is equal to 1. Mass number is equal to 1. But number of neutrons, 0. Number of neutrons, 0. Clear? And another isotope of hydrogen, second one, 1H2. The name of this isotope is deuterium. ड्यू का मतलब क्या है 2, प्रो का मतलब क्या 1, डी का मतलब 2. So in the isotopes of second isotope of hydrogen, how many protons are present? How many protons are present in the second isotope of hydrogen? 1. That is equal to 1. That is same as atomic number. Same as atomic number. Okay, same as atomic number. And how many electrons are present in the second isotope of hydrogen? 1. Because atom, that is also it is also an atom. Atom is electrically neutral. Or how many neutrons are present? 1. Yes, very good. 1. Why? 2 minus 1, that is equal to 1. 2 minus 1, that is equal to 1. Or what is the mass number of this hydrogen isotope? 2. And the first thing is 1. Here it is 2. The mass number different because of the difference in the number of neutrons. Because of the number of neutrons present in the nucleus of these two isotopes of hydrogen are different. Because of this number of neutrons, difference in the number of neutrons, then the mass number will change. And that is the reason for the isotopes of an element. And one more isotopes of hydrogen, third one, 1H3. Here 3, mass number is 3, is called tritium. So what are the 3 isotopes of hydrogen? Protium, deuterium and tritium. What are the 3 isotopes of hydrogen? What are 3 isotopes? Protium, 1H1, deuterium 1H2, tritium 1H3. Tritium 1H3. These are the 3 isotopes of hydrogen. And in the first isotope of hydrogen, number of neutrons is equal to 0. In the case of second isotope of hydrogen, number of neutrons is equal to 1. In the third isotope of hydrogen, number of neutrons is equal to 2. So number of neutrons, that is not same, that is different. The number of neutrons present in the nucleus of all these isotopes of hydrogens, that is not same, that is different. Because of this difference in the number of neutrons, the mass number, that is also different. And the mass numbers that different, so it is called isotopes. So what is isotopes? Atoms of same element having same atomic number but different mass numbers are called isotopes. So these are the isotopes of hydrogen. These are the isotopes of chlorine. 17Cl35. 17Cl35 are the isotopes of chlorine. These are the isotopes of chlorine. And the different isotopes of oxygen, atomic number of oxygen, Pushkar, atomic number of oxygen. 8. Atomic number of oxygen, that is equal to 8. So 8O16, 8O16, 8O17, and one more, 8O18. These are the different isotopes of oxygen. These are the different isotopes of oxygen. So, how many neutrons are present in the first isotope of oxygen? 8. 8. 16 minus 8, that is equal to 8. How many neutrons are present in the second isotope of oxygen? 9. That is equal to 9. That is equal to 9. And how many neutrons are present in the third isotope of oxygen? That is equal to 10. And the number of neutrons present in all these isotopes are not same, different. Because of this difference in the number of neutrons, the mass number also different. And because of this different mass number, it shows which property? Isotopes. Okay, these are the isotopes. So what is isotopes? Clear? Isotopes are the atoms of the same element having same atomic number but different mass number. Clear? Atoms of same element having same atomic number but different mass number. What are different isotopes of hydrogen, Kush? What are the different isotopes of hydrogen? Protium, suction, protium. Formula? Protium. Suction, protium. Formula. Means symbol of protium. 1H1. Naviga, deuterium. Hit Chowdhury. Deuterium. Deuterium. Aaron, 1H2. 1H2. Other Sharma, other tritium. Tritium. 1H3. 1H3. These are the different isotopes of hydrogen. Protium 1H1, deuterium 1H2, and tritium 1H3. 1H3. Here number of neutrons are different. Because of this number of different neutrons, then our mass number that is also will change. And the mass number that is also different. And because of this different mass number and same atomic number, these elements are called isotopes. Isotopes. What is isotopes? Clear? Atoms of same element have same atomic number but different mass number. What is the electronic configuration of the first isotope of chlorine? Electronic configuration of the first isotope 287. And electronic configuration of second isotope of chlorine 287. So in both cases, the number of valence electrons remains same. In chemistry, if the number of valence electrons same, that shows similar chemical properties. Similar chemical properties. In chemistry, the chemical property that determines the number of electrons present in the outermost shell of an atom. In chemistry, the chemical property determines the number of electrons present in the outermost shell, that is the valence shell of an atom. In the case of first isotope of chlorine, the number of electron in the outermost shell is 7. In this case also 7. Here, in the case of hydrogen, protium, number of electron present in the outermost shell of protium is equal to 1. And number of electrons present in the outermost shell of the second isotope of hydrogen, that is deuterium, is also equal to 1. And tritium, number of electrons present in the outermost shell, 1. So, here next question, very important question. All the isotopes of an element shows identical chemical properties. Why isotopes of an element have identical chemical properties? Because reason, yes, reason why?
Sir, this is because all the isotopes and of an element sir, because
all the isotopes of an element have identical electronic configuration containing same number of valence electrons. Therefore, all the isotopes of an element shows identical chemical properties or similar chemical properties. Clear? All the isotopes of an element have identical electronic configuration containing same number of valence electrons. Therefore, isotopes of an element shows similar chemical properties. Clear? Why the isotopes of an element show similar chemical properties?
Of an element in electronic configuration is same, when the valence of the electronic configuration is same, then they show similar chemical properties.
All the isotopes of an element have identical electronic configuration containing same number of valence electrons. Therefore, isotopes of an element show similar chemical properties. Adhyuta, why? Why the isotopes of element show similar chemical properties? Containing same number of valence electrons. Containing same number of valence electrons. Somyak, why? Why isotopes of an element show similar chemical properties? Why?
Isotopes of an element show similar chemical properties because they have identical electronic configuration, so they have same number of valence electrons.
Okay, same number of valence electrons. Anishka, why isotopes of elements show similar chemical properties? Isotopes of an element show similar chemical property. Why?
Isotopes of same element show similar chemical properties because their electronic configuration is identical.
All the isotopes of an element have identical electronic configuration containing same number of valence electrons. Therefore, they show similar chemical properties. But the physical properties are different. The physical property determines the mass. What is the mass is different. Because of the different masses, different atomic masses, the physical properties are different. But chemical properties, they show similar chemical properties, but physical properties that are different because of the different atomic masses. Different atomic masses. Here masses are different, 1, 2, 3. But number of electrons present in the outermost shells, that is same. So they show similar chemical property, but the physical properties are different. And because of the existence of the isotopes or different atomic masses, the atomic mass of the some elements are in fraction. You know what is the actual atomic mass of the chlorine? Atomic mass of the chlorine. Okay, very good. 35.5 U. 35.5 U. Why? Reason. Because of the existence of the isotopes. Because of the existence of the isotopes. Some numerical problems are there that is based on this fact. Clear? So, listen. Why isotopes show similar chemical properties? Because all the isotopes of an element have identical electronic configuration containing same number of valence electrons. Clear? Same number of valence electrons. But the physical properties are different because of the different atomic masses. Okay, all the isotopes of element have different atomic masses, so this shows different physical properties. And why some element shows the fractional atomic mass? Because of the existence of the isotopes. Because of the existence of the isotopes containing different atomic masses. Existence of the isotopes. What is isotope? Clear? What is isotope, Tanishk? What is isotope, Tanishk? What is isotope? Tanishk, what is isotope? Divyanshi, what is isotope?
Number of atoms of an element having
What is isotope? Shivesh, what is isotope? Rahani.
the isotopes are the atoms of the same element which consist of the same atomic mass with different
Atoms of the same element having same atomic number but different mass number are called isotopes. The different isotopes of hydrogen: protium 1H1, deuterium 1H2, tritium 1H3. In all these cases, number of neutrons are different. Number of neutrons present in the protium is equal to 0, deuterium 1 and tritium 2. Because of this number of neutrons present in the nucleus, the mass number of the isotopes of the element are also different, because of the number of neutrons different. So mass numbers that is also different. Mass number that is also different. Clear? Clear? So isotopes. Any doubt? Applications of isotopes or the uses of isotopes. Listen, the first one. The isotopes of uranium, that is U-235. U-235, U means uranium, symbol of uranium. U-235 means the mass number of this uranium is 235. So U-235, the isotopes of uranium-235 is used as a fuel for the production of electricity in nuclear reactors. It is used as a fuel. Where? For the production of electricity in nuclear reactors. It is used as a fuel for the production of electricity. Which isotope is used for the production of electricity in nuclear reactor? Uranium-235. So uranium-235 is used as a fuel for the production of electricity in nuclear reactors. Second one. The second isotope, that is cobalt, capital C, small letter O, cobalt 60. Cobalt 60 is used in the treatment of anyone? Cobalt 60 is used in the treatment of
Cancer.
Yes, very good. Cancer. It is used in the treatment of cancer. Cobalt 60 is used in the treatment of cancer. Cobalt 60. Uranium-235 is used as a fuel for the production of electricity in nuclear reactor. Second, cobalt 60 is used in the treatment of cancer. And iodine 131. Iodine 131 is used in the treatment of lack of iodine produces which problem? Goiter. That is goiter. Okay. So iodine 131 is used in the treatment of goiter. It is used in the treatment of cancer, and it is used for the production of electricity in nuclear reactors. Cobalt 60 is used in the treatment of cancer. Iodine 131 is used in the treatment of goiter. And one more, carbon 14. Anyone? Carbon 14 is used to determine the age of the fossil. It is used to determine the age of the fossil. So carbon 14 Carbon 14 is used to determine the age of fossil. Age of fossil. These are the different isotopes, applications of isotopes. Uranium 235 is used as a fuel for the production of electricity. Cobalt 60 is used in the treatment of cancer. Iodine 131 is used in the treatment of gout, and carbon 14 C14 is used to determine the age of fossils. So these are the different applications. What are the different applications of isotopes? Kush, what are the different isotopes of isotopes? Uh, Means what are different applications? To explain.
Uranium 235 is used as a fuel production for electricity in nuclear reactions.
Nuclear reactor.
Nuclear reactor. Second, cobalt 60 is used in the treatment of cancer.
This used in the cobalt 60 that is used in the treatment of cancer. Iodine 131 is used in the treatment of cancer. Sorry, goiter. And one more.
And fourth, carbon 14 is used to determine the age of
Carbon 14 is used to detect or to determine the age of fossils. Age of fossils. What is isotopes? Isotopes. Write exam. Isotopes are atoms of the same element atoms of the same element having the same atomic number but different mass numbers. But different mass numbers. The different isotopes of chlorine are the different isotopes of chlorine are first one 17Cl35, 17Cl35. Second 17Cl 17, yes, very good, 17Cl37. 17Cl37. Next question. What are the different isotopes of hydrogen? Aditya, what are different isotopes of hydrogen?
Sir, protium, deuterium, and tritium.
Protium formula?
Sir, 1H1.
Deuterium?
Sir, 1H2.
1H2. Tritium?
1H3.
1H3. Okay. I know. The different isotopes of hydrogen are First, protium, (1H1), protium, 1H1, deuterium, 1H2, tritium, 1H3. One H3. Next question. What are different isotopes of oxygen? What are the different isotopes of oxygen? What are different isotopes of oxygen? 8O, 16, 8O, 17, and 8O, 8O, 18. Next question. All the isotopes of an element, have identical chemical properties. Give reason. Granth, answer. Granth.
Because they have same identical electronic configuration, and so they have same electronic.
Valence electron. Okay. Okay. Valence electron. I don't. All the isotopes of an element have identical electronic configurations. Identical. Note कर दो यश.
They are noted.
Okay. All the isotopes of an element have identical electronic configuration containing same number of valence electrons. Therefore, all the isotopes of an element show identical chemical properties. Identical chemical properties. Next question. The physical properties of isotopes of an element are different. Give reason. The physical property that listen, which factor that determines the physical properties? Mass number. Yes, mass. Yes, mass. And the physical properties of the isotopes of an element are different. Give reason. Answer. The isotopes of masses of the isotopes of an element, the masses of the isotopes of an element are slightly different. Therefore, the physical properties of an element are slightly different. The physical properties of the isotopes of an element are slightly different. Next question. What is the reason for what is the reason for the fractional atomic masses of elements? Fractional atomic masses of elements. Answer. The fractional atomic masses of elements are due to the existence of their isotopes. Existence of their isotopes. Existence of their isotopes having different masses. Having different masses. Having different masses. Next question. What are the applications of isotopes? What are the applications of isotopes? The first one. An isotope of an isotope of uranium, an isotope of uranium, write in bracket U, capital U dash 235. This 235 represents atomic number or atomic mass? Means mass number or atomic number? Yes, mass number. Mass number. Next, an isotope of uranium complete kar do. An isotope of uranium 235 is used as a fuel for the production of electricity in nuclear reactors. Is used as a fuel for the production of electricity in nuclear reactors. Is used as a fuel for the production of electricity in nuclear reactors. Next, second, the isotope of cobalt 60, cobalt, right in bracket CO60, capital C, small letter O. Isotope of cobalt, right in bracket cobalt 60, is used yes in the treatment of cancer, is used in the treatment of cancer. Third, an isotope of iodine, right in bracket I-131, is used is used in the treatment of goiter, in the treatment of goiter. Next, an isotope of carbon, right in bracket C14, is used to determine the age of fossils, is used to determine the age of fossils. Next question लिख देना. What are the different isotopes of neon? Neon. Neon. Atomic number of neon? 10. है ना? 10. So what are the different isotopes of neon? The different isotopes of neon, that is Ne 10, 20, comma Ne 10, 21 or Ne 10, 22. These are the different isotopes of neon. Uh, Next question. Next question. Name an element. Name an element and name an element in which the number of neutrons present in the nucleus of that element is equal to 0. Name an element. Hydrogen. Yes, very good. Hydrogen. ये कौन सा आइसोटोप में? इन विच आइसोटोप? प्रोटियम है ना, प्रोटियम. Yes, protium. Name an element in which number of neutrons present in the nucleus of that element is equal to 0. Number of neutrons is equal to 0. Next question. Why isotopes of an element have different mass numbers? Anyone? Why? Why isotopes of an element have different mass numbers?
Due to thin neutrons.
Yes, very good. Different number of neutrons. I don't. Because they contain different number of neutrons. They contain different number of neutrons in their nuclei. In their nuclei. Clear?